So first I want to do a quick review of what we have seen and then go into a little bit more depth and show you some more advanced features that you will need for your lab and your project, and of course future projects that you will be engaged in. So first of all, we have seen that a MongoDB database is made up of collections, and these collections store documents. And these documents are nothing but JSON objects that you are already familiar with. And a document is nothing but a set of key value pairs. The key being a string, and the value could be really anything. It could be a string, it could be a number, it could be an array of strings or an array of objects. It could be an object, the value itself. So that's basically what a document is. And the collection of documents that have similar schema and a similar purpose, we put them together in one collection. And that's basically the model in MongoDB. So database is made up of collections, and a collection is made up of documents, and a document is made up of key value pairs. The key is a string, and the value could be really anything. That's the basic idea. Now, the analogy in the relational database, so the collection could be mapped to a table, and the documents could be mapped to a row on the table, and the property could be mapped to a column in the table. So that's basically the analogy to the familiar relational database that you already experienced in the database course. Okay, but of course we are going and using the document-oriented database because it is a better fit, the best fit for web applications, because we heavily use JSON as the data format, and we can just keep that JSON as a unit and save it and retrieve it from the database without converting it to multiple tables as done in the relational database. So one skill that you really need to develop and you will further enhance as we move forward in this course is the document schema design. So you already seen database design in the database course. This is kind of complementary, and that you need to adapt that design to this document-oriented database. So the basic idea I already explained, that you in a document-oriented database like MongoDB, you will be designing a document which is a complex structure that is made up of attributes, and these attributes, the values of these attributes could be objects or they could be an array of objects. Of course, these features are not possible and not allowed in a relational database. In a relational database, a column in a table must be a single value. You cannot store multiple values in a column in a relational database. And this is very different when it comes to a document-oriented database. The good thing is, in a relational database, you have to have multiple tables to store related objects. So for example, if you have an owner and cars, and an owner has one or many cars, in a relational database, you have to store it in two tables. And you join these two tables using a foreign key. So for example, here a person has a person ID, they own one or many cars, you have a car table, and then you link the two by adding an owner ID to the car table, and then you can link them. But in a MongoDB database or a document-oriented database, you can store the list of cars with the owner object, within the owner objects. And these are basically, will become a sub-document within this document. Now, one of the major design decisions when you are creating a document, okay, is when you have a sub-document or a document within a document, is to decide whether to embed it or to reference it. Okay, these are two major decisions you need to make. And here I will give you some examples and some guidelines. When should you embed a document? Embed means like this. This is embedding. I took this other document, which is car1 and car2, and I put them within the major document. That's called embedding. The other option is that I could have a separate collections for cars, and then I can just store the ID in the owner. So I'll just have an array of IDs rather than array of documents. So this style is called embedding, and the other style is called referencing. Okay. And this decision is not an easy decision. So we will see shortly how we can make an optimal one. So it depends on how the data will be used and also depend on the document size. But let me go through, first of all, and try to understand the two models and the advantages and disadvantages. And then I'll show you or let's discuss together the guidelines, when to use each of the styles. So first of all, with embedding, what are the advantages of embedding?
Everything is inside of the file. You can access it all without needing reference.
Yes, not files. Here we all talk about documents. Yes. So it's one unit. So you retrieve it as one unit and you save it as one unit, which means you do one operation and you are done. So you don't need any joins. No joins, because all is together as one unit. And you can, because it is if it is one unit, it is guaranteed to either succeed or fail as one thing. But if you have multiple operations, let's say you store the owner in one collection and you store the cars in another collection. So when you store the owner, it could succeed, and storing the cars may fail for some reason. And then basically you get inconsistency. This is a very bad situation to end up with. But when you have them together, you are avoiding that scenario of partial update of the database. Partial update is very dangerous. Nobody wants that because it introduces consistency. So if you keep it in one unit, you don't have that problem of risk of inconsistency or partial database update. But what is the cost? Yes. Let me just, what is the cost? The cost is your document could grow and could become large. And there is a limit, in MongoDB, there is a limit that the maximum document size is 16 megabytes. You have to keep this in mind. Of course, it's a large document, but still keep it in mind that this is the limit. As a transaction in a database world, you can group multiple operations as one unit, and you want them to all succeed or all fail. Yes? So now, currently, the current version, let's talk about MongoDB in particular. The current version only has the concept of transaction in a single collection. If you insert one document in a collection, it is guaranteed to either succeed or fail. Now, why it's failed? It could be a validation error. It could be that the schema that it violates the schema that you might have defined in your, let's say, in your Mongo schema. Or it could be that there's a network failure, or you exceeded the size of the document. Maybe the document is 16 megabytes already. You cannot insert, you cannot add to it any more things. So it could fail, okay? But if you insert into two collections, MongoDB does not give you any guarantees that both of them will succeed as one transaction. But this is changing with the next version, as advertised by MongoDB people. Next version of MongoDB will have transaction cross collections. But now, at least for now, the transaction is per collection. So you cannot have an atomic transaction cross collections. Yes, you can only guarantee for the current version for a single collection, which means if you insert a document or update a document, one document within one particular collection, it is guaranteed to either succeed or fail, but not cross collections. So this is embedding. This is the advantages and the disadvantages of embedding. What about the referencing? What is the advantage of referencing? is that you will end up with smaller documents. So for example, the owner only has the owner details, and the cars are that just like object IDs. So the document is definitely much, much smaller. It is less, in this case, it is less likely that you will exceed the 16 megabyte limit. And if the document, let's say the subdocument, has information that you don't frequently access. Let's say in the first design, if you do embedding, whenever you get the owner, you also get the cars. But maybe your application does not care most of the time about cars, and you are getting this extra information that you don't need. So in frequently accessed information, you don't need to bring them unless if you need them. And also there is no duplication of data. So especially if you have something that is shared among multiple documents. So yes, so let's take an example. Let's take an example of course sections or course sections. Let's say we have a database course, we have a web development course, we have programming course, and inside the course we have the room details, where it is located. So for example, the room could be this room I-217, and we can say this room is located here and it has 50 seats, for example. And we repeat that same information if we do embedding. We repeat the same information in the course database. We repeat the same information in the course programming. Now, if the seats, we expand this room and we put extra seats, which means we have now 60 seats instead of 50, we have to update in multiple places. So, you know, in this scenario, in this particular scenario, you end up with duplication, and duplication is not very healthy when you want to do future updates. But in the case of owner and car, there is no risk of duplication, because the car most likely is one owner. It will not repeat in other documents. But you know, you need to keep this in mind. Whether the sub-document can be shared or repeated in other documents, or it is unique. So if it can be repeated elsewhere, it is not a good idea. It might not be a good idea to embed it, because you might end up with duplication. Where to use which one is the optimal one, okay? It's a design decision, yes? And this design decision, you want to make it with principles, not just you scratch your head, you bring your flower and say, embed reference, embed reference, embed reference, and then, oh, bingo, we have embed. You have to do it with some principles in mind, and you try to come up with the optimal design decision. And this is what will be coming next. Now, in this world, nothing is for free. You gain in one side and you pay on the other side. This is very normal. And that's what design is. You try to balance the trade-offs and you choose the optimal decision for the particular scenario. There is no one solution fits all. You have to think about it and come up with the optimal one. Okay, so what are the limitations or the disadvantages of embedding? You have to do 2 queries to retrieve the information. So if you want the owner and the cars, and you want with referencing, you have to do 1 query to get the owner and another query to get the cars. The other one is you cannot update related information atomically in one transaction, at least in the current version. But MongoDB is planning to support transaction cross-collections in the next 4.0 version. Okay, so let's now start and talking and discussing when to use embedding and when to use referencing. First of all, one thing to consider is the type of relationship between the main document and the subdocument. So one example of relationship is one-to-one. So let's say here is an example, a medical procedure and the results of the medical procedure. So the results of a medical procedure, it's one result. So it's a one-to-one relationship. So this result cannot really exist on its own. It is called a weak entity. Maybe you have already seen this also in database. It's a weak entity, cannot exist on its own. In this scenario, in a one-to-one relationship, usually the best strategy is to embed. Because there is no risk of duplication, and usually there is a principle here. Data that are read and written together should live together. We always get the procedure and the results as one unit, and we save them as one unit. There is no risk of duplication, and it makes sense to keep them together. Okay, the other scenario is when we have a one-to-many relationship. A one-to-many relationship. So, for example, here, the patient and the procedures. You know, patient in hospital, they might have different procedures. So you have two choices. There is either embedding. This is what embedding will look like. So this is the patient details, and these are the procedures. There's an array of procedures. Or you can go with referencing. Okay? And this is how it looks like in referencing. In referencing, in the array of procedures, you just store the IDs, and the IDs will be pointing to the procedures collection. So you have two collections, the patients and the procedures. Two different documents in another collection. Yes.
Collection for patient, collection for procedures.
Yes, two collections, one for patients, one for procedures. And this is very similar, this design is very similar to the relational way. Yes. Although in relational database, you cannot have an array. Okay. In relational database, how would you design this in relational database? Foreign key, where do you place the foreign key? In the many side, in the procedure. So the procedure will have foreign key to the patient. Okay. But in document-oriented database is much more flexible. You can put it in here if you wish, or you can put it in the one-side table, in the one-side document, or in both. In here, we decided to put it as an array in the patient document. Now, putting patients and procedures in the same collection, MongoDB will not be complaining to you. Okay, it's up to you, but it's a nonsense. You know, there is the cohesion principle. It's a very important principle in design. You put things that are similar purpose and they are semantically and meaningfully related together. You don't put things that are not related together. You know, when you walk into a supermarket, you don't find your tomato with milk and with, what is it? With the shoes rack. You know, things that are related and close together, you'll find them together. It's very similar. In the real world, that's how it works. In our programs, we should keep that mental model that we are familiar with, to keep things that are related together and not to mix things that have nothing to do with each other. Okay, so when do we choose embedding and versus referencing? These are some guidelines. Now, if you have one to few, yeah? If you have one to few, for example, customer and address. Customer might have different address. I might have a work address, a home address, maybe one or two, okay? Three. It's a one to few. In this case, there is no risk. You go ahead and embed them. Plus, this address most likely is unique to that customer. Most likely. There might be small chances where multiple customers living in the same place, but very small. If you have one to few, you go with embedding. If you have one to a large number of items, you go for referencing. If, for example, customer and orders, customer can have so many orders. You may exceed 16 megabytes. Also, when you get the customer, you get all the orders, although even the orders that were placed in 1970 that you don't really care about, you will get them. So why should you go for that? Like in a one-to-many, like a large number of related items, you go with referencing rather than embedding. But one-to-few, with no risk of duplication, you go with embedding. Yes, please. Yes, Khani.
Like a specific number?
No specific number, like one to few. By the way, it's not just one guideline. I mean, you consider those together to make the decision. Okay? It's not just one indicator. You consider as many indicators as you can to make the decision. The second indicator The things that are frequently queried and updated together, it's good to keep them together. They are frequently updated and retrieved together. You keep them together. So you don't have a need to access the embedded objects by themselves. For example, let's take the example here. Often queried and updated together as in single query. For example, the book and the chapters. The book and the chapters of the book could be, we always, when we get the book, most likely we are also getting the chapters of the book. Also, we might not need to access the embedded object by themselves. For example, the order and the order items. When we get an order, we get all the items related to the order, which means what items did we place in that order. And we go for embedding when there is no risk of data duplication, where the embedded objects will not repeat in other documents. Then we go with embedding. Now, we go with referencing when we have one-to-many, and the many is a large number of items. And related data changes frequently. Here. So here, for example, we have a video and a video count, view count. Okay? Now, the video itself does not change much. It does not change much. But the video count changes all the time. So instead of, because there is different frequency of update. So it is a good idea, things that change more frequently, to put them separate. So it's easier to update them, rather than bringing the whole document, changing one small piece, and then saving back the document. Instead, the things that change frequently, you might consider putting them outside the main document to make it easier to update. Referenced entities. Entities that are, we call them a reference entities because we use them in many documents, maybe even in many collections, such as the session and the room. You might have multiple sessions, or let's say course sessions, and each course session has a, like one of the attributes is the room. Because this room is shared cross sessions, it's not a good idea to embed it because you will end up with data duplication. And also referencing, when you have in mind that if I embed, I run the risk of going across the 16 megabyte, then you go for referencing. The other way, the other guideline, if the subdocument has a large number of infrequently accessed fields, like the embedded document, you have fields or you have content in that document you don't care too much about. Very rare you go and get them. So you better not embed them. You better put them outside and just reference them. You know, those are basically the guidelines. You don't take one guideline. You try to use as many guidelines as possible to justify your decision. So these are some examples. These are some examples. Here I have a customer that has one or many addresses. So in here, definitely it's one to few addresses. With customer is very few addresses. No problem, you can here one to few, and plus these addresses are more likely to be unique and uniquely related to this customer. So embedding here is the best design. Another example here is users and tasks. Users, you say we have an enterprise or a company, and we have a lot of tasks that get created and assigned to users. So these tasks could be so many of them. So it's one to many. So it is better to not to embed them, but to reference them. So like the user will have a list of, or maybe the task, one way to do it, I think the best way to do it is in the task to reference the user. So the task will have a user ID, and then we can, if we need to get who owns the task or to whom the task is assigned, we can just look up the user ID. So we have seen one-to-one, usually one-to-one, usually just most of the time, close your eyes and embed it. One-to-many depends. I gave you some guidelines. Now, many-to-many, This is an example of many-to-many, where I have hospital, I have physicians or doctors, and doctors, they might work or do some services in multiple hospitals. So in a relational database, this is how you do it. You have some bridge table to link the two. The primary key of the first table and the primary key of the second table become a composite, become a foreign key in this bridge table. That's how you do it in the relational model. In the document-oriented database, you have two options, either to embed or to reference. Embedding means in hospital, you list down who are the doctors working at that hospital in an array of assigned to property physicians, okay? Now, you can do the same for the other hospital and so on, but most likely you might end up with some duplication if a particular doctor or physician is working in multiple hospitals. So in a many-to-many, there is a risk of data duplication. Hence, usually it's best to use, in most cases, it is best to use referencing rather than embedding. For example, here in hospital, what you can do is you can list down the IDs of the doctors working at that hospital. And in physicians, you can also, if you wish, depending on what you're trying to do, you can also list the IDs of the hospitals where the doctor or the physician is working at. So you can have a bidirectional relationship between the two documents. So in here, you don't need the bridge document like in a relational database. Because in a document-oriented database, a property could be an array of IDs, which is not feasible in the relational model. So I hope you really appreciate the flexibility that the document-oriented database offers to us compared to the relational model. Okay, so now that we understand the design, the schema design, like we will see now how we can do it in JavaScript using a library called Mongoose that I introduced earlier. And what Mongoose allows us to do, the first thing it allows us to do, it allows us to create the schema of our documents. What do we mean by the schema? It's basically the structure of the document. Not only this, I can add some validation rules, and I can also reference from one document, I can reference another document. Yes? Now, from the schema, I create what is known as a model. A model is nothing but a class that allows me to interact with the collection. So a model is a really maps to a DB collection, and then once I build a model, I can use it to read and write to the MongoDB database. So let me just do a quick review of what we have seen and quickly jump into something new. Schema, what is schema? What do we use the schema for? Very good. Define the structure of the document. What is a model? It's kind of an intermediary, like kind of a representative. It's an abstraction. It's an abstraction that we use in our program. We talk to the model, and the model knows how to translate our actions to the database. Okay, so it has nothing to do with the repositories and services. So let me show you now very super quickly. Here is a book model that we discussed before, if you remember. Yes, after we build the schema, we make a model out of it. Okay, in one line. I will explain this a little bit more. So in here, let's first have a look at this first schema here that I explained, if you remember last time. So in here, there is, for example, a review schema. You know, if you go to Amazon, for example, if you buy a book or an item, you can add a review. So usually in a review, what are the properties I find in a review? The author, who did the review? It's typically a string. A rating, it is what? A number. And here, I put some validation rules. The minimum is 0 and the maximum is 5, and it is required. It's not an optional one. Review text, it is a string. I'm just here. I'm not trying to give it to make it realistic. What I'm trying to do here, show you all the possible features. So don't consider this as the best practice, or I'm giving you variations. This is a learning, not something you will put in production. Okay. So in here, lazy boys. What the lazy boys will do? This is the lazy boys. They just put the data type and go on. This is more perfectionist. They put everything in a nice way, which is a valid point. But I want to show you both. Okay. Now, the text is a string. It is required. And here, trim true. What this trim true does?
Gets rid of extras.
Very good. The white space is on the left or the right before it stores it.
But not what's inside.
No, of course. Created on, have a look at this. Created on is a date, and by default, even if you don't supply it, it will be added to the document, and the value will be the current date and time. So it's very powerful. So the schema is not only the structure, you can define some default behavior, you can define some validation rules. So here is the review schema. I decided not to put the reviews in a separate collection. I decided to make it embedded. It's maybe not the best decision, but here it's demoing the features of the schema. Okay, now the book. Have a look at the book, how it is defined. So ISBN is a string, the title is a string, the author is an array of strings. The publisher is an object. It has the name and the country, and the category is a string, and so on. The available is a Boolean, and a true or false, and it is required. By default, it will be true. Okay, created on the reviews. Have a look at the reviews. The reviews is an array of the review schema. I could have, as I showed you last time, I could cut this one and paste it here. But just to keep it modular and easier to understand, I put it outside. And by default, the reviews will not be in the document. By default, it will be undefined. Okay, the store. Have a look at the store. The store is not embedded. The store it's a reference. Okay, so what I have here, have a look. I have another schema called store, and a store has two attributes, a name and city. Okay, and then basically what I have here is once I create the schema, I export it I expose it as a model. So this is how I create a model out of the schema. So a model is nothing but a representative of the collection. It maps to a collection in MongoDB. So what will be the name of the collection in MongoDB? Stores with S, because a collection is a list of documents. But as a model, the good practice is to have it without S. Okay, it's just convention, how the Mongoose people have designed this. Now, if I want to read and write stores, I will basically use this store class. It has all the magic to help me read and write from MongoDB database. Okay, now, in the, let me go back to the store schema, to the books schema. So here is how I define a reference. In here, I'm saying, oh, the store is nothing but an ID. It's not an object that I embed. It is an ID, and this ID is referring to the store collection or the store model. So this is how I do it. So I'll say the type. This is basic. By the way, this is an array because a book could be stored in multiple stores. So this is an array, and this array, the elements of the array will be what? IDs. And these IDs are pointing to the store IDs that are stored in which collection? The stores collection. Is clear the idea? So here, this is an example of referencing, and this is an example of embedding. Is clear so far? Okay, so now I define the schema. It is, okay, here I just to show you some validation. I'm saying here, just a small example of validation. If somebody tries to store a book, what I will do here, I will make sure, I'll go to this ISBN and make sure that the ISBN, the minimum length is 3. If they give me an ISBN 1, 2, the save will be rejected. This is how they have. There are some built-in validations. They are here inside, but this is custom validator. So here is an example of validator inside. Min value is 0 and the max value is 5 as a value. But in here, there is no built-in validator to say the minimum length. So I have here, just an example. Of course, you can do much more than this. In here, I'm validating to make sure that the length is at least 3 characters. So once I define the schema, what should I do? Create a model out of the schema. How do I create a model out of the schema? Just ask Mongo, please go ahead, create a model for me called book, and this model will be pointing to which collection? Books in MongoDB. And what is the schema of this book collection, or this book model? The book scheme. What can I do with the model? Use it to read and write. Okay, so here it is. Here is an example. I go to my repository. You're already familiar with the concept of repository. The only difference now is that I'm reading and writing from a database rather than from a file. But in terms of role, is the same. If I want to create a new store, how do I do this? I go to the store model and call the method create and give it an instance of the new object. And that's it. It will be added. If I want to get all the stores, find and give it the where clause, there is no where clause. You know the where in SQL statement? Here you give me all. Now, if I want to get how many stores in Doha, for example, I'll say here, get stores, store.count, city, Doha. It will give me, it will filter the stores based on the city equal Doha, and then it will count how many stores I will get. I will get here a number, 1, 2, 3, 4, and so on. Okay. Distinct categories. You know the books have categories. And if I want to know what are the distinct categories I have, programming, database, fiction, so on, I can get them all. Okay. Now, if I want to search the books, here, if I do just find with the empty curly braces, I am getting all the books. Now, if this one is not undefined, if it is undefined, that's it. I will get all the books. But if I put here, let's say, category programming, then I will add a where clause. Can you see here where? Query.where, and I put category is equal to the category that is passed as a parameter. And then here, I do query.populate store. What is this query.populate store? Okay, so you remember the store, is it a reference or embedded? The store here in the schema, remember the schema? It is a reference. Now, when I get it, I will get an ID. But maybe I need the store details. I don't want just the IDs. How do I ask the repository to grab me the store details as well? I'll just say populate and the property name. Very powerful. It will do another query back to the database, replace the IDs with the actual stores. So you see, at the end of the day, you are not losing much. Although you are using references, you can grab the actual objects very easily. But of course, populate will do extra query. Yeah. Okay. Book count. You're already familiar with it. So if you know the ID of the book, you can get it by find by ID, and you give it the ID. You can also find by find one, because ISBN is unique. You can do find one. I don't want a list. It's one of them because it's unique. So where ISBN is equal this one. And by the way, select is you can specify which properties you want, or you can do also minus. Can you see here minus? Give me all except these two. It's very powerful. I don't want the reviews. I don't want the version. Yes, space between them. That's it. No comma like SQL. Space between them. Very good. Now, if I want to add book.create and give it the object, it will go ahead and add. I am looking by author, getting books by author. Remember, authors is an array. So because I need to look up the array, so I cannot do equal. I'll say here, give me the books where the author is one of these authors. So it's an array. It's looking up the array. say if the author happens to be one of the authors in the array, grab me. I'm interested to get that book. Now for updating, the way you do update is you call the method update. You give it the ID and then the book, but make sure you delete the ID. The reason why you should delete the ID, because the ID cannot be changed. The ID is non-changeable. So what you do is you do update, give it the ID, and give it the object you want to update. Before that, you move. Sorry, can you please wait for 5 minutes? 5 minutes, please. Okay. So you delete the ID and then you update this one. Okay. Now for delete, very simple. Remove and give it the ID you want to remove. Yes. Add. Very powerful, by the way. Here, I have a reviews. Where is the reviews? Here. What I can do is reviews is an array. Yes? So what I do, I get the book, I go to the reviews and push the review and then save. Can you see here what's going on? Reviews is embedded. Reviews is an embedded document. So how do I do it? Push and then save. No, if they are not embedded, I will save the reviews in the reviews collection, get the ID and push the ID to the array. So what you do here, you can also aggregate. Remember group by? Have you seen group by? Select group by in SQL. Okay, you can do exactly the same here in very powerful way. So here what I want to do, I want to get the books, I want to group them by what? Category. And then I want to get the average number, the average pages, and the count. How many books in this category? You know, the books have number of pages. Some books are 50 pages, some books 200, some books 300. I want to get for each category, like let's say fiction, programming, web development, the average number of pages per book, per category, sorry. Per category. And also I want to know how many books in each category. So what I do here, I use this, the syntax is a bit kind of unusual, but it's very, very powerful. So I can do here, it's basically the first step I group. Can you see here? I group by what? Category. So the way I do it, I have this special property called underscore ID. I must use this one, underscore ID. And then I specify the field I want to group by, preceded by $. This is the syntax, basically. And then the rest of the attributes, I have to use one of operation, sum or average, similar to group by. You have seen group by, you can do sum, average, and so on. Sorry, just 2 minutes. We still. Okay. Then have a look at this. What I'm doing here, can somebody please tell me? Only I want to get the categories where the pages is greater than 200. Okay? And also I want to sort the pages by descending order. I want the longest books, the books with the longest pages followed by this in descending order. And I only want the top 5.
Why you didn't put these conditions in the group?
No, very good question. So the way it works is a pipe. Are you familiar with pipe in Unix? So the output of this one is the input to the next step. Yes, like basically the output of one stage is an input to the next. These are steps. The first step is I group, the second step is I filter, the third step is sort, and the fourth is I limit the result to 5, the top 5. Okay? So definitely we'll practice this, inshallah, in the lab and in your project. But this is very, very powerful. Yeah? So I hope you get a bit of idea. The only way to master this is do it. Do it in the lab, do it in your project. Now you have enough kind of knowledge.